Hi, this is Prasanna from Wave Academia. In this video, we are going to discuss about electric vehicle regenerative braking system using Matlab. This is one of the important concepts in electric vehicle which is available only in electric vehicle. Whenever the driver applies the acceleration, there will be a flow of voltage from battery to machine. So whenever driver applies the brake, there will be some excess energy which is available in the machine. So that will be transferred from machine to battery. That means while the vehicle is at running condition, whenever the driver applies the brake, at the time little bit amount of battery is going to be get charged. This is nothing but it is a regenerative braking system. So first of all, before we moving on to the simulation, first we'll discuss how actually the regenerative braking system circuit is working. Let me consider this is the simple circuit which contains 4 switches. This part is nothing but consider it is a battery, and the combination of armature winding and back EMF is considered as machine. That means the machine will both working in motoring mode as well as generating mode. So this circuit consists of 4 switches Q1, Q2, Q3 and Q4. It's a power electronic switch. Either you can use IGBT or MOSFET. During normal conditions, during driving mode, that means whenever driver applies the acceleration at the time, the switches Q1 and Q4 is going to be in on state, whereas Q3 and Q2 will be in off state. So at the time, this is the flow of current in the circuit. I'm starting from battery. It's flowing through Q1. Again, it is flowing through the machine. At this time, the machine is working in motoring mode. Q4 is on. It's creating the closed loop now. So this is the arrow mark I'm putting. This will be the flow of voltage from input side to output side during driving mode. Whenever the driver started to apply a brake, remember in regenerative braking system will effectively work between 10 to maximum of 50 to 60% of braking only. If you apply more than 60% of braking, that means that you are about to stop the vehicle. At the time, this regenerative braking mode work actually. That means it won't charge the battery. Okay, whenever driver applies the initial stage of braking, at the time both this battery as well as the machine will be connected in a series circuit. Now if you look at this case, at this time the switch Q1 and Q4 is going to be in off state, whereas Q3 and Q2 will be in on state. So look at this case, it is going through Q3. Now it is going through the machine. Again it's going through Q2. I'm just putting the arrow mark. This is the flow of current which will create a closed loop. So at this time, both the battery as well as the machine will be in series circuit. So now the basic principle of science will work. We know that energy will always flow from higher energy state to lower energy state. While acceleration mode, the battery will be higher energy state and the load is lower energy state. There will be a flow of voltage from battery to machine. But in this case, at the time of braking mode, this machine will become a higher energy state and battery will go to the lower energy state, because the power required by the machine will be lower than the power delivered to the machine. Therefore, this machine will become higher energy state. At the time, at this stage, this series circuit will decide, okay, in which flow the voltage is going to be happen. So once the initial brake is transfer to 20 to 30% of braking. That is actually the regenerative braking mode. Again, Q1 and Q4 it's going to be in on state, whereas Q2 and Q3 will be in off state. So at this time it is starting from the machine, it is flowing through like this. So at the time battery will get charged. This is the same thing we are going to simulate with the help of Matlab. Then you will get a clear idea when the battery is getting charged, when the battery is getting discharged, and how to give the input to the machines. Those things we'll discuss. Clear? Now I'm moving on to the Matlab. So the parameters I need, the components I need is 4 switches. According to the circuit I'm going, I need 4 switches, a battery, machine, and a resistor and a capacitor. These are all the things which I require. Let me take the DC machine. So if you double click this DC machine, whatever the preset model I'm going to select, let it be it's a model number 1, that is 5 HP machine, 240 volts, 1750 RPM, and field winding required is 300 volts. So whatever the mechanical input I'm choosing, it's a torque. This is very, very important. This is the way you are going to give the inputs. And the remaining parameters, let it be same. I'm not going to change. Okay. So if you want to excite the DC machine, you are supposed to provide the field winding. Okay. So let me take a DC voltage source. So this DC voltage source should be at least minimum of 300 volts. That's why we choose here. So make sure that this DC voltage source is 300 volts. Now I'm going to feed the input to the machine with the help of this load torque. Remember, when the torque is negative, which means that driver applies the brake. When the torque is positive, when the driver applies the acceleration. Okay, so this should be very clear before we moving on to the simulation. When the torque is negative, it means that the machine is working in braking mode. When the torque is positive, the same machine is working in a acceleration mode. So first, as of now, I'm going to give the inputs through a step signal. Simply connected the step signal here. So let me take this is a torque input. Double click it. You can change the step value. Let me take this as exactly 7 seconds. I'm going to change from initial value of -20 to final value of 10. So what it is mean that it is actually step time is starting from 0. From 0 to 7 seconds, my torque value is -20. That means the system is going to work in braking mode. From 7 to remaining stop time seconds, so whatever the stop time I'm using it 10 seconds. From 7 to 10 seconds, my torque value is 10. That means at that time the machine is going to work in motoring mode or acceleration mode. Okay, there is a meaning of this block diagram. Getting applied. I need a series RLC branch because I need inductor as well as capacitor. So this capacitor is connected in parallel with the machine. So we're having a inductor, and I'm going to place 4 switches. Let me take a MOSFET. So in this MOSFET, it's having a 3 terminal and one more parameters are called M. I don't want this M port. If you want to measure the current flowing through the switch or voltage across the switch, you can use this M port. Otherwise, it is not necessary. You can disable it. There are 2 ways you can disable the thing. One is you can use the terminator block. Okay. So if you use a terminator here, while executing the program, this M port, it won't create you any warning. It won't throw you any warning. This is one way. Another way is double click the switch, uncheck this show measurement port. Okay, this is the another way. Similarly, I need 4 switches. Let me say that this is S1. See, as per the circuit I am going. You can refer the circuit. S1. S4. S3. And this one is S2. I'm just going to connect the switches accordingly. So one side my machine is there, another side I'm having a battery. So now the battery is connected with this combination of switches. If you want to measure the battery parameters, so actually you can measure state of charge, current and voltage of batteries. You need a bus selector. For flipping, you can use Ctrl plus I. If you double click it, then you can come to know what are all the parameters you can able to measure. First remove this one. Select state of charge, because I see if you want to measure current voltage, okay, no issues. But as of now, I'm going to measure only, okay, let us measure current also, nothing will happen. So if you want to measure only SOC, you can do it accordingly, okay. Click apply. go to view, change the configuration parameters, that is number of input ports as 3. First one is state of charge, second one is current, third one is voltage. Now if you want to see the machine parameter, then take as bus selector, simply connect it to this M port. Of course, I'm going to measure the speed, that is in radian per second, armature current, field current, electrical torque, apply, okay. It will be 6. First one is speed, second one is armature current, third one is field current, fourth one is electrical torque, and then the fifth one is the input torque, and the sixth one you can take SOC. So this is for just comparison how actually the things are working. Now the important thing is we have to pulse these gates. We have to provide pulse to the gates. Okay, for that I'm using a pulse width. We take a pulse generator. So here make sure that when S1 and S4 is on, at the time S2 and S3 is going to be in off state. See, I'm going to generate a pulse signal for S1 and S4. Then how to generate for S3 and S4? It's very simple. Take the invert of signal. This will give you S2 and S3. That means if S1 and S4 is 1, this will be 0. If this is 0, this will be 1. Okay. Let me create a go to tag. Let me take this is P side tag. So make sure that, make it as a practice, always the tag visibility will be global. In this case, it won't disturb even though if you put it in the local also, but make sure that, make it as a habit, make always a global, because if you are using the subsystems, only this tag will work if you make it as a visibility as global. Similarly, take one more go to tag and renaming it, this is inside tag. Inside tag. So what I'm using, it's not symbol. That's all. This is not. Name of the block is pulse generator. Just keeping it somewhere. Okay. Similarly, I'm taking the corresponding from tag. The corresponding from tag is connected with S1 and S4. Similarly, corresponding end tag is connected with S3 and S2. Just organizing, just a minute. To run this block, you need a power guide. Power guide is mandatory. Just need to place it somewhere. So now I'm going to feed the inputs. We already declared what is the machine actually. I chose preset model 1. The parameters are, it's a 5 HP machine, 240 volts, 1750 RPM and 300 volts. For the excitation, I supposed to use 300 volts DC in a field value. Okay. And then go to torque, whatever the input we are giving, it's a low torque is, I'm starting from minus 20 and that value is changing at exactly at 7 seconds from minus 20 to 10. The capacitor value I'm choosing, the filter value is, let me choose, it's a 150 microfarad. 150 microfarad. And the inductor value I'm choosing is, it's a 5 millihenry. Okay. No need to change the switching parameters. Let it be a default. Here, one thing what you need to do is go to pulse generator. You have to fix the time period. So as of now, I'm using the time period is 2 e power minus 5. So why I'm using 2 e power minus 5? We know that f is equal to 1 divided by t. This t is nothing but 2 e power minus 5. Then you can easily calculate the switching frequency of MOSFET. It's coming around 50 kilohertz. So this 50 kilohertz is nothing but the switching frequency of MOSFET, which describes how fast I'm going to make the switch on and off. Okay, whereas whatever the pulse width I'm going to use is, let it be, it's a 25%, which will decide how much time you are going to make the switch on. That means if you take this switch on, off, keeps on going. This pulse width is nothing but it is a duty value. This 25 refers 25% of time I'm going to make the switch on. The remaining 75% of time the switch will be in off state. Okay, so that is the input I'm going to give for the switches. And go to battery. Whatever the battery I'm using is lithium ion battery. Okay, nominal voltage I'm choosing it's 240 volts and let it be 20 ampere hour. Here it's a very important parameter is initial state of charge. Whenever you are doing any kind of simulation with batteries, please always start from 50% of initial state of charge. Then only you can able to understand whether the battery is getting charged or discharged. Suppose if you used 10% and if the battery is getting charged, you cannot visualize how the battery is getting charged. Okay, so make it as a thumb rule. Whenever you are doing a battery work, always start the initial state of charge with 50%. Then only you can able to understand whether the battery is getting charged or discharged. Click apply. Okay, now the program is ready for execution. If you run the system, this is quite complex program, and according to the system's configuration, it will take a lot of time. Okay, yeah, it's done now. If you look at the battery's SOC, okay, if you look at the battery's SOC, initially the battery was getting charged. Why? From 0 to 7 seconds, the battery is getting charged because I used the value of minus 20 as a torque value. I already mentioned if it is a minus 20, that means that the system is working in braking mode. Therefore, the battery is getting charged. So once it reaches 7 seconds, I change the value from minus 20 to 15. That means it is working in acceleration mode. Therefore, the battery is getting discharged. So accordingly, the corresponding current and voltage, you can see it. If you want to see the same output, just take this, the entire machine configurations. If you want to see the output, go to view, go to layout, change the separate layouts. Yeah, if you look at this, say this is the comparative thing. Okay, and if you look at this case, always the armature current will follow electrical torque pattern only. And if you look at the field current, if you are seeing that it is a variable current, actually it is not a variable current. The field current will be always constant, but still it is showing it is not a constant. Why? But if you look at the values, it's a very minimum value. These are all negligible values. Okay, so what you can do is, if you consider these are all very negligible, then I can say that the field current is constant, and this is the corresponding speed in radian per second. Okay, so this is the way actually the regenerative braking system is working. Suppose if you want to change the torque, instead of step, you can use any kind of drive cycle source in real-time case. Okay, so what I'm doing here now, instead of this drive cycle source, I'm using signal builder. Okay, let me do it. Let me try it one. I'm just deleting this torque. So instead, I'm taking signal builder, because through step I can give only 2 changes, but in signal builder you can give n number of changes. Okay, in real time, if you want to use, please try the same thing with drive cycle source. Okay, go to signal builder, go to signal, go to new. See what is the use of signal builder and all. You can create any number of signal, constant signal, step, pulse, sawtooth, square, or if you want to generate a noises, Gaussian noise, pseudo-random, Poisson noise, you can do with the help of signal builder. I'm going with the customized signal. Here I'm going to put up the X and Y values. So let me take some 8 values. Okay. So here the number of values in time must be equal to number of values in Y. Okay. See, whenever the torque value, see Y value is in positive, that means that the torque is positive. If the torque is positive, means the vehicle is in acceleration mode. When the torque is negative, the vehicle is in braking mode. Okay, clear? So I'm deleting this previous case. I'm going to simulate the system only for 6 seconds. That is more than enough for me. Go to axis, change the time range, choose maximum time as 6. Okay, so according to this case, according to this input, now my battery is going to get charged and discharged. Save this one. Now connect it with this terminal. Change the start time only up to 6 seconds. More enough because I'm having input only up to 6 seconds, right? If you run it, yeah, it's done now. You can see the output. See now how the battery is getting charged. See during up to this portion it is discharged. Again it is charging. Again it is discharging. Again charging. Again. So after that it's completely discharged. After this portion it's completely discharged. Okay. So this is the way actually you can learn how actually the regenerative braking system is working in real time. Clear? I hope this video will give you enough information about how the regenerative braking system is working, how to actuate the switches in circuit, those things and all. Thank you. Please kindly subscribe to the channel if you're really interested. And if you have any doubts in Matlab and techniques, whatever we discussed, drop a mail to the mentioned mail ID. Thank you.